Assalamu alaikum dear students. We are discussing continuity of a function. Now today we are going to discuss continuity of a composition functions. You know you studied about composition functions. Now if we have a function h of x which is of the form of or which is equals to g of f of x means gof of x, then this h is called as the composition of two functions g and h, and this g and f. Here f, if we consider to be a function, in order to define this gof, we need f a function from a to b and g from b to c, such that f of a equals to b means this f is either onto or a domain of g equals to a range of f. This means f of a equals to b, that is range of f equals to b. Then clearly this h is function because we defined h to be g of f of x to is the function from a to c. A to c, which is defined by h of x is gof of x, which is simply defined by g of f of x. Now suppose that we are given this f is continuous at point a, because if we consider a to be the point of this set a, and g is continuous at point f of a, because domain of g equals to the range of f. If a is the point in this set a, then f of a equals to b is the point in b is the point in b. Here b is the domain of f. This means that g of b is simply as f of a. F of a is the point. So if we have this f is the function at x equals to a, and g is the function of g is continuous at f of a, then we need to prove h is this continuous at x equals to a, means this composition of two functions is continuous at this point. Now since f is continuous at point a, means that limit x tends to a, f of x is f of a, because it is the definition of the continuity of a function at a given point, that is limit exists and equals to the value of the function at given point. Similarly g is continuous at f of b, f of a, because domain points or this g are of the form of f of a, f of a, that is limit x tends to f of a, g of x is g of f of a, g of f of a. Now we have to prove that this h is continuous, that is we need to show this limit x tends to a, h of x equals to h of a, because this means continuity at point a. Here h is defined as, this g of f. This means that in order to prove this, we will prove limit x tends to a, g of f gof of x equals to gof of a, gof of a. Now limit x tends to a, g of f of x is simply limit x tends to a, g of f of x, a g of f of x. Here from second, limit x tends to f of a, g of x is simply g of f of a. So from this we conclude that limit x tends to a, g of f of x is simply g of f of a, g of f of a, because from first limit x tends to a, f of x is f of a, that is f is continuous at a. Limit x tends to f of a, g of x is g of f of a, that is this g is continuous at point a. Now g of f of a is simply g of f of a, because composition gof of x is simply g of f of x, that is g of f of a, g of f of a. So here a is the point in the domain of this h. This means that this limit of gof is simply exists and equals to the value of the function at given point, this means that this g of f means gof is continuous at this point a. In particular this h is this continuous at point a, because h is defined by g of f of x. So in this way we can say that if we have two functions where we are able to define their composition, that is either gof or fog, then if these two functions are continuous, implies that their composition is also continuous, that is composition of two continuous functions at a point is always continuous. Now if we consider the problems of this type, we are we have to prove that this h defined by cos x square and h defined by mod cos x are continuous functions over their entire domain. Domain means here that they are continuous at each and every point, means arbitrary point of the domain. If we consider first h of x equals to cos x square, and let g of x is cos x, f of x is x square. Now if we arrange this domain and the codomain of these functions in such a way that we are able to define the graph, then g of f of x is simply g of f of x. Now f of x is defined by x square. This means that g of x square, and g of x square is simply defined by g of x equals to cos x, that is cos x square. So this means that this h, which is cos x square, is simply composition of two functions. Here this cos x square is not equals to cos x whole square, because cos x whole square means cos square x means multiplication of coses, cos into cos. But here cos x square means here the square or the index 2 is simply to this angle, that is x. That is why cos x square is never equals to cos x ka whole square or cos square x. If we have this cos square x, then we can easily prove this by using the algebra, because multiplication of two functions is continuous. But here we have composition. Square is to angle, not to whole function. This means that this cos x square is actually composition of two functions. One, the cos x, and second one is the this x square. Here you know that cos x trigonometric functions are defined or continuous over each and every point of their domain. Polynomials are continuous over R. This means that this g and f are continuous at each and every point of their respective domains. Now here we are able to define this graph. So this means that their graph composition is also continuous at any point. This means that cos of x square is continuous. Now the second one is mod of cos x. Let g of x is mod x, f of x is cos x. Then graph is f of g of f of x, g of cos of x, which is simply mod cos x. Now mod cos x here is composition of two functions. One, the modulus function, second one cos x. Domain of this is this g of x. This means that it is continuous. You know it. Trigonometric functions are continuous. In particular, this cos is continuous, and this mod cos x is composition of two continuous functions. So by previous theorem we can say that this mod cos x is also continuous. So in this way you can prove any composition, or you can prove any problem of this type, or when we have a function which is composition of two functions. Now in order to prove this composition function is continuous, you simply need to show that the individual these functions are continuous. If they are continuous, this means that the main function is continuous. So this was all about the continuous functions. Inshallah, from tomorrow onwards we shall discuss this differentiability. So thank you.